Hello everyone! Today, we're going to explore one of the most important topics in mathematics, quadratic functions and equations. But before that, let me ask you a question. Why does this topic matter in real life? When you throw a basketball into the air, its path forms a smooth curve. Or how fireworks form perfect arcs before bursting. Even engineers use these curves when designing bridges, satellite dishes, and car headlights. All these curved shapes are modeled using quadratic functions. So when you learn quadratics, you're actually learning the mathematics behind real-world movements, designs, and technologies. Quadratic functions help us predict, design, and solve problems in sports, engineering, economics, technology, and even video game physics. A quadratic expression is any expression where the highest power of the variable is 2. It always takes the form x superscript 2 plus bx plus c. Remember, a cannot be 0, because without the x superscript 2 term, the expression becomes linear, not quadratic. When we graph a quadratic function, we get a smooth curve called a parabola. There are only two shapes. If the parabola opens upward, it has a minimum point. If it opens downward, it has a maximum point. These special points are also called turning points. Every quadratic graph has an axis of symmetry, a vertical line that cuts the graph into two equal halves. Its position is controlled by the value of b. The value of c gives the y-intercept, which tells us where the graph crosses the y-axis. And the value of a? It decides how wide or narrow the parabola is. Small leads to a wider graph, while a large results in a narrower graph. The roots or x-intercepts of a quadratic equation are the points where the graph meets the x-axis. Depending on the graph, a quadratic can have 2 roots, 1 root, or no roots at all. So remember, quadratic functions are everywhere around us. They help us understand motion, design structures, and solve real-world problems. By mastering quadratics, you're developing mathematical tools used in engineering, physics, architecture, and even sports.